Hi, this is James Page with ECOC TV. Infinera have a rich and long history of innovation in the telecoms market and are constantly reimagining their approach to telecoms networks. That's why I'm so pleased to be on their stand and pleased to be with Rob Shaw, their SVP of Marketing. Rob, lots going on here at ECOC this week, lots of conversation about Coherent Technologies. What's driving growth there?
Well, there's one thing that's inexorably true about bandwidth, in that it grows, and it continues to grow. So what Coherent Technology is a technology that enables very high rates of transmission. So it enables you to transmit a lot of information using a single transceiver. Historically, this type of technology was used primarily in long-haul and submarine networks where there's huge amounts of bandwidth between continents, between cities, or between major data centers. But what we're seeing now is a significant growth in the bandwidth at the edge of the network with things like 5G and enhanced broadband and even edge computing, and it's driving the capacity requirements at the edge of the network up extremely rapidly. And it's very quickly now coming to a point where it's crossing the ability of direct detect lower speed optical technology to handle it. And so it's pushing the need for this coherent technology closer to the edge. So instead of dealing with a core network where you might have hundreds of locations, you're now dealing with an access and aggregation network where you have thousands of locations. Not quite as much bandwidth, but a huge number of increased locations that need to be connected with this more advanced higher speed technology. So it's really pushing the demand for the technology, and it's pushing for different types of solutions because the edge of the network not only has some different dynamics to it, but the traffic pattern itself is a little bit different. And so that's where you're seeing really this drive for not only new innovative types of coherent technology, but certainly technology in these smaller pluggable form factors that can be more easily deployed in a wider variety of scenarios.
Okay, great. Well, let's talk about pluggables. You've got one here, and we've got a demo running on the stand today. So what can we see? What are we looking at?
Okay. Yeah, this is exactly what Infinera is looking to do with coherent technology. Certainly we've been building coherent technology for an extremely long time, but as I mentioned, the demands at the edge of the network are quite a bit different than in the core of the network. In the core of the network, most of the traffic pattern is very point-to-point, large location to another large location. But as you get to the edge of the network, the traffic patterns change to be much more hub and spoke. Think of a mobile network. I've got a cell tower. That one cell tower needs to talk to hundreds or thousands of individual mobile phones. Well, historically, if you had built a mobile network the way we built optical networks, at that radio, at that cell tower, you'd put one little tiny radio for every single mobile phone you need to connect to, right? It's completely impractical. The way they build mobile networks is one big giant radio that covers the entire spectrum. So this is exactly what we're trying to do with our pluggable technology, is not only be able to solve those point-to-point demands, but also using the same transceiver be able to do a point-to-multi-point configuration where one larger laser can talk to a bunch of smaller lasers. And this enables a significant amount of increased efficiency at the edge of the network, now that we have technology that can actually support the type of traffic demands at the edge of the network. And so that's what we're demonstrating. In 2019 at ECOC, we announced the concept of this technology that we call XR optics. And now we are seeing the fruition of that technology as we bring the first actual XR optics-based transceiver to market. And that's what we're demonstrating here is our soon-to-be-released XR optics, we call ICE XR, version of a transceiver, which we can build into either the smaller QSFP-DD form factor or into the larger CFP2 form factors, both with exactly the same performance, but they can fit different types of interfaces on different types of devices. So that's the key highlight for Infinera at the show.
Okay, great. That's really interesting. Thanks for going into that in some detail. So the sort of end uses, the benefits, the new things that this is going to bring to your end customers, what are those sort of really key benefits? Can you tell us a bit about that?
Yeah, a good question. So again, the whole idea of being able to have a transceiver that really is designed to support the type of traffic at the edge of the network results in significantly less equipment necessary. So because we've been using point-to-point technology, even at the edge of the network where the demands are point-to-multipoint or hub and spoke, what we've had to do is have mirrored transceivers. So I put a transceiver on either side. If I have 16 locations, that means 32 transceivers, one at each side, and we've been using electrical aggregation to kind of aggregate those together and bring them back to the core. So that's resulted in a large number of switches and routers that really do nothing more than aggregate optical signals for multiple end locations. Well, with these multi-point transceivers now, I don't need those electrical aggregation devices anymore because I can use a single transceiver to aggregate all that traffic. This means at the edge, of course, I need one transceiver for each location, but at the aggregation location, I just need one. So instead of 32 transceivers, I now have 17 transceivers. So you can cut the number of transceiver requirements by almost half. In addition, I can get rid of all those intermediate electrical aggregation devices because I can now aggregate that traffic optically, and I don't need these switches and routers and all of their interfaces to do that. So it cuts out equipment, it dramatically simplifies the network because I have fewer pieces of equipment, it can lower the amount of power requirements and make networks more efficient in general. One of the real benefits of XR optics when used in multi-point applications is not only can I take a single transceiver and communicate with multiple endpoints, but I can actually dynamically distribute capacity to them as well. Instead of nailing up a 100 gig link between 2 points, I can have a 400 or 800 gig transceiver at the core, and that can dynamically distribute traffic now to these edge locations. So really, I can not only connect just 16 transceivers to it, 16 endpoints, I could do 32 or more, and then send maybe 25 gig to each all the time, and then burst traffic to each one dynamically as I need to. So again, it increases the efficiency of the network even more by being able to dynamically allocate from a single transceiver to numerous end transceivers. So in summary, it's reduce the amount of equipment, cut CapEx, cut the amount of equipment, cut power, and simplify the network. We've had network operators perform their own independent studies that demonstrated over 70% of network savings as a result of using this type of technology.
Thank you very much for explaining it. It's fantastically interesting, and would love to talk to you more. But for now, thank you for inviting us onto your stand and for explaining all of that. And we hope you're having a great show.
Yeah, always ECOC is a great show and increasingly important as this type of technology, as we said, becomes more prevalent, more necessary, and more important to network operators in more locations. So we expect a long and bright future for this show, and certainly plan to participate heavily as the years continue forward.
Great. Well, thanks very much.
Great. Thank you.